Joe is driving east at 60 kilometers per hour. Dave is driving south at 70 kilometers per hour. Both cars are approaching the intersection of the two roads. At what rate is the distance between the cars decreasing when Joe's car is 0.4 kilometers and Dave's car is 0.3 kilometers from the intersection? So let's start by sketching this scenario. So we have Dave driving south, like so. So he's driving, this is Dave, driving south at 70 kilometers per hour. And then we have Joe driving east at 60 kilometers per hour. So these are our rates, and we are asked to determine how the distance, at what rate the distance between the cars is decreasing. Now they are approaching this intersection. Okay, so that's the point where they will meet, and we also know the distance, how far away they are, the distance to the intersection. So Joe is, if this is where Joe is, that distance there is 0.4 kilometers. And if Dave is there, the distance to that intersection from Dave is 0.3 kilometers. Okay, these distances are decreasing because they're approaching the intersection. So that means that when we are expressing the rates for Dave, so it's the vertical axis here, we're going to refer to that as y-axis. So it's going to be the rate dy dt. So the rate at which y is changing with respect to time will be negative 70, because y, the distance, is becoming smaller as he's approaching the intersection. For Joe, so that's the horizontal axis, we're going to call that x. So the rate at which x is changing with respect to time is going to be negative 60. And again, it's a negative rate because the distance is decreasing. What we want to determine here is the rate at which the distance between the cars, which is going to be this, is changing, right? So we're going to refer to this as z. This is the distance between the cars. And what we're trying to determine here is we're trying to determine the rate at which the distance between the cars is changing with respect to time at the point when Joe is 0.4 kilometers and Dave is 0.3 kilometers from the intersection. Okay, so we can now see that we have a triangle here. We have a right angle triangle. And anytime we see a right triangle, we should think Pythagoras Theorem. So we can express we can express the relation between the sides using the Pythagorean theorem, and it will also allow us to determine what z is. How far apart are they actually at this point? So let's do that. So we have x squared plus y squared equals z squared. So this is going to be 0.4 squared plus 0.3 squared equals to z squared. And this is going to be 0.25 equals z squared, and that means that z equals to 0.5. Like so. The next step would be to differentiate our Pythagorean theorem here. So we will have to use implicit differentiation here. So it's going to be the derivative of x squared with respect to time plus the derivative of y squared with respect to time equals to the derivative of z squared with respect to time. We will apply the chain rule here. So this is going to become 2x, that's the outside derivative, times dx dt, plus, again, the chain rule, outside derivative is 2y times dy dt equals to, same thing again, 2 times z dz dt. And now if we take a look at our differentiated expression, we know, well, first of all, we're looking for dz dt. This is what we're looking for. We know this rate, right? That's how fast Joe is driving. That's his rate, negative 60. We know dy dt. That's the rate for Dave. We know x. That's how far away Joe is from the intersection. We know y. That's how far Dave is from the intersection. And we know z. That's how far apart they are. So we can now just plug in all the quantities that we know and then just solve it for dz dt. So it's going to be 2 times 0.4 dx dt is negative 60 plus 2 times y is 0.3 times dy dt, that's negative 70, equals to 2 times z, and z was 0.5, times dz dt. And if we evaluate this, the left-hand side, and divide by, well, we're going to end up dividing by 1, right? We are going to get dz dt that equals to negative 90. So that means that the distance between the two vehicles is decreasing at a rate of 90 kilometers per hour.